Welcome to our 6th event of the Knowledge Worker Innovation Series. So since we started this event, we here at Thomson Reuters actually created a data innovation lab based in Boston. And we are hiring here. So, and we also, we are in the Innovation District. And one of the things that's fantastic about the Innovation District is actually working with our partners here. So we've also partnered with Mass Challenge to create a big data track to really foster innovation and entrepreneurship around big data. And these events are really opportunities for us to connect and collaborate. And so I'd like to welcome our partner at the Mass Tech Collaborative, who are leading Governor Patrick's Mass Big Data Initiative to expand the Commonwealth's position and leadership in big data. This is really exciting for us, and more exciting than anything is to have all of you students here. It's really exciting for us to have you here and in our space. And so the initiative actually has chosen today's event as the first Mass Big Data track, which brings all of you from various schools in the area to meet with some of the leaders in big data. And so we decided to actually present you some of the entrepreneurs working in this space. And so we're going to meet today startup founders and CEO from Koa Lab, giving us lightning talk about their companies in the big data space. And so each of these CEOs is going to give us a 10-minute presentation of their company, and then they'll join me on a panel for Q&A, and then we'll open it up to everybody. So what I wanted to do is first give you a quick overview of who we have here as our guests. First, you'll hear from Marilyn Matz, who is CEO and co-founder of Paradigm4, an open-source next-gen data science platform for researchers, data scientists, and analysts in clinical informatics. She's also a serial entrepreneur who has been recognized for outstanding technical and leadership contribution. She founded Cognex, a publicly traded and global machine vision company. Hello, Marilyn. Next, we'll hear from Adam Towvim. He's the CEO and co-founder of Trust Layers, a new company commercializing MIT's research to automate data policy compliance. Adam, too, hails from a background of innovation and entrepreneurship with over 2 decades of experience with data and privacy. Hi, Adam. Thanks for joining us. And finally, we'll hear from Andy Palmer. Besides being an awesome mentor to me, Andy is a serial entrepreneur and founder of Koa Labs, Tamr, and Vertica, a pioneering big data analytics company which is sold to HP. Andy has advised more than 50 startup companies, and he'll be giving us a lightning talk about his new company, Tamr, a data connection platform reducing time and effort, connecting and enriching data source. Welcome, Andy. So I think what we're going to do now is go through the lightning talks. So I'll invite Marilyn to the stage.
Great. Hi, everyone. So Paradigm4's SciDB is a radically new kind of database. It's a computational database, and it's been designed specifically to help people mine insights from all that new kind of data that's being generated today. Genomic sequence data, Bitcoin transaction data, could be geospatial data, location data from cars and cell phones, and all of the kinds of devices and equipment that are sending time-stamped data about their performance. And we're named SciDB because the science world, the climatologists and the physicists and the astronomers, these guys were working with big data before that meme was even coined. And when you look around at scientific instruments, you know, you're looking at telescopes and satellite imagery and seismometers, you know, these were the original machine-generated data creators. So this stuff's been around before big data was around. And then here comes the commercial world, following in the science footsteps and facing the same challenges. So we did a survey of data scientists a few months ago, and 71% of these guys said that it was data variety diversity that was causing them more headaches than data volume big data. And you guys know that, I think, because one of the ways that people are creating rich new insights is by bringing together different kinds of data. It doesn't come from just mining one data stream. And then we asked these guys sort of what kinds of data are they using or anticipating using, and 3 of them were top. First is time series data, and you get that because almost everything that's sending data, it matters where it came from and when it was sent. Geospatial data, that's all that data from cars and cell phones, location data. And lastly, graph data, which people are using a lot to analyze networks. And that's sort of my example before about Bitcoin transactions. It's a network. These are graph operations. So what's SciDB? And I wanted to tell you a tiny bit about the technology. So what it is it's 2 products in one. It's an all-in-one database with built-in scalable analytics, and it's a massively parallel distributed database. It's got built-in complex analytics. And by complex analytics, I mean some of the more interesting math, like principal component analysis, clustering algorithms, machine learning. This is the stuff that you use to get the really interesting insights out of data. It isn't about the low-hanging fruit, about sums, counts, and roll-ups anymore. And the other thing that's really pretty unique about SciDB is it's natively an array data model. And when you think about all of that new kind of data generated, that data is structured. And it matters about the structure, and it matters about the ordering of the data. And SciDB is just, you know, when you think about arrays are just naturally the right data model for dealing with sequencing data and geospatial data and stuff like that. And then lastly, it's programmable from R and Python. And this is important because those are the analyst-friendly languages that are out there. So I wanted to start out by sharing 2 success stories about SciDB, and then I'll tell you, make a few suggestions on what kinds of questions you should ask yourself as you're thinking about what analytical software tools to use for your use cases. So the first story is fun. It's the particle physicist version of finding a needle in a haystack. And what these guys are doing is they're looking for deep matter, and they're using detectors deep underground. And they've got like 20 billion signals, and they're looking for 100 key events. And the way that you guys can relate to this is think about if there's like a rainstorm in Boston for a bunch of hours, like a couple of hours, and there's one red raindrop in all that rain. That's what they're looking for, okay? So, you know, the way they do this, it's an iterative process. You know, they got their data, they set some parameters, change the parameters, iterate again, and they keep going until they get a good result. And to do that required, you know, some pretty complicated scripts to both write and to run. And then once they got that, before using SciDB, these guys were storing data in flat files. And it took them sometimes 2 days, sometimes 2 weeks to go through each single iteration. And that approach just wasn't going to get them to 50 terabytes and beyond. And so with SciDB, each iteration took them 2 seconds. And to use their words exactly, they said, this is like a productivity revolution. So there's one. So now move to the commercial world. Recommendation engines. Recommendations engines are behind almost every e-commerce platform. And the data scientists in the room know that there's a math function called singular value decomposition that a lot of folks use to power recommendation engines. So we were dealing with this e-commerce company that wanted to scale up their business from a domestic business to a global business. And what that meant for them is, you know, all of a sudden they had a very sparse space when they started looking globally at customers, vendors, and product SKUs. And they ended up having a matrix that was 50 million by 50 million with about 4 billion non-zero elements, okay? That's really sparse and really hard, and here's what happened. R and Mahout blew up, okay? And not only did SciDB complete that, but we also did it on inexpensive commodity hardware grids. So these are common stories that you hear in the big data world. Folks have data in flat files and data warehouses in the Hadoop file system, and the current meme right now is in data lakes. And what they end up doing is having to search through that lake, find what data they need, yank it out, transform it into whatever data structure R, MATLAB, SAS, scikit-learn need, and then find out that those math packages don't even scale, so they're hosed. So there are a bunch of issues here. With data in files, it's pretty hard to select out subpopulations or geographic regions or time windows. So data in files doesn't really cut it. Second thing is, if your data is big, you shouldn't be moving it around. That's a big performance hit. And then lastly, if your data is critical, eventual consistency just leads to eventual troubles. All right, so I just wanted to pop up a little and talk about how to choose the right software for your analytical use cases. First of all, the channel Mike Stonebreaker, who's the CTO of our company, and he's a pretty renowned database researcher. He's also a legend in the Boston area. Paradigm 4 is his 8th company. Tamr with Andy is his 9th company. So the guy's got magic. Andy's brilliant. But to channel Mike Stonebreaker, one size doesn't fit all. And you guys are going to need multiple tools for the different things that you need to do in your analytical workflow. And so let me just tell you a couple more stories. We've already talked about one of the questions you have to answer: does your data have inherent ordering? And when you're dealing with data like time series data, geospatial data, and images and matrices, look, what are matrices? A lot of the linear algebra operations that you guys need to do data mining and machine learning, you want to be able to run on the data natively in the native data format. And the Hadoop file system doesn't preserve that ordering. Relational databases don't preserve that ordering, and SciDB does. So you want to be working with something that's going to make your job easier by preserving the ordering. And then next, you need to combine data from multiple sources. Do you have public data and private data? Do you have different kinds of data? Well, in order to integrate data, you do something called a join. And the issue here is that HDFS and key value stores, they don't do joins at all or not efficiently. And then consistency. Do you have multiple people trying to access the data at once, and you don't want them to clobber each other? And do you need your data to be consistent after every transaction, or eventually consistent? A lot of the gamers in our company got completely roiled about the folly of eventual consistency. There was some game called Elder Scrolls Online, and these guys were losing their bank accounts and having to wait until their bank account reconciled. And you think that's interesting, but that's just a game. There was a recent theft from Bitcoin operators that showed that eventually consistent databases just don't cut it for banking applications. And then lastly, what kind of math do you want to do in your database? There's the easy stuff that's easily parallelizable, and then there's the interesting stuff that's going to give you the deeper insights. And that's stuff like the singular value decomposition, the machine learning, the generalized linear models, a lot of interesting clustering algorithms. So then just to wrap up, who cares about all of this stuff? This is financial investigators who want to look at networks of Bitcoin traders. It's biotech companies that want to do high throughput screening and biomarker discovery so they can do drug retargeting and new drug discovery. It's precision medicine companies who are trying to figure out what works for whom and what's the best way to get the most effective outcomes. It's equipment manufacturers who want to be able to predict maintenance 2 weeks out instead of 2 days out. And it's IoT companies that are trying to figure out what to do with all of the sensor and device data that they're collecting. So the bottom line is you're going to need multiple software products. You're going to need a scalable computational database when you want to answer bigger and harder questions. Thanks.
How's everyone doing?
Good.
Great. So I'd love to see a show of hands here. How many people have either Facebook, Twitter, or Google Plus profiles? How many people here have ever used a credit card? And how many of you have ever applied for a loan? Good. And the last one is, how many of you have health insurance? There's a couple of hands that didn't go up there. So here's the news for all of you. There's profiles out there about you. And more organizations have the ability to gather personal information about us as patients, as consumers, and even as citizens. And there's a lot of attention right now in the media, a lot of attention focused on what that means to us as people. But what most of us don't realize is that it's as big of a deal for the organizations that are gathering all this data. Organizations face a tremendous amount of opportunity of how to make use of that data, but they also know that they need to make use of it responsibly. And how do I know this? Because I've spent more than two plus decades going around and trying to amass a tremendous amount of personal data and responsibly make the best use of it. Now that's credit data, it's about data as we browse the landline web, the mobile web, it's data about us and the phone calls we make. All of that data has a tremendous amount of potential. And there's never been a greater opportunity to collect all that data. We all read about that in the news every day. But what you don't stop to think about, especially as an individual, is what is the organization doing with all that data? We've got a tremendous focus in the news on who should have access to the data. But what we like to think about at Trust Layers is how is that data being used? How is an organization making the most use of that data and making sure that they're maximizing the opportunity for that, but also ensuring that they're using it responsibly? So collecting data. It's a story that we all hear today. We've got Marilyn and Andy and all the folks at Thomson Reuters know there's a tremendous opportunity with technology today to be able to collect all that data. But what's the next step beyond collection? Well, there's two more steps to it. The first step is correlation. My favorite story about correlation is most people don't realize this, but there's a very high correlation between the people who purchase those protectors on the bottoms of furniture, protectors on the bottoms of wooden chairs, and being a good credit risk. Why? You're taking good care of things, right? There was an interesting article recently in the New York Times about a correlation between folks who have a tendency to purchase things from mail order catalogs, purchase things from internet shopping, and a correlation between those folks and people who make use of ER services for non-urgent care, right? Who would have thought? Who would have thought this correlation? Now, what does that mean? Does that mean I think I'll buy something on Amazon, oops, I'll end up in the emergency room? No. But here, a health insurance company wanted to understand who were the folks making use of the ER services when they could have been using an urgent care facility. They could have been using a walk-in clinic. And so they brought together and correlated data from a data broker and their own data about folks who are using medical services, right? Never before have organizations been able to bring this data together so easily. So then what do you do with all that data once you draw those correlations? Because you can start to see great correlations between folks who buy in supermarkets, buy natural products, and those folks who are likely to buy hybrid cars, right? You can make great decisions about individuals. You can give them far more relevant content. You can also make decisions about subprime consumers. People who have less than stellar credit, why should they be forced to give a $1,000 deposit just to get a cell phone? If you know they pay their rent reliably, if you know they pay their utility bill reliably, then there's an opportunity to draw correlations there and not just collect that data, draw correlations, but also catalyze. And that's where Trust Layers is focused. Letting organizations create a catalyst for using that data. So collecting it, correlating it, and really being able to catalyze that data and have an ability to control the proper use of it. So whether it's about making responsible decisions about extending medical insurance, different types of medical policies to individuals, when you think about all the information that can be gathered about us when you're making a consumer credit decision, when in a financial services environment, you're trying to account for the proper use of data in an environment where you're making insurance decisions, extending loans and credits. And that's what comes back to what I was asking in the beginning. All of us have information that's being collected about us, and I don't mean to establish that in a creepy kind of way. In my previous life, we were building very large data sets about individuals in the mobile ecosystem. There's nothing more personal than someone's mobile device and all the data exhaust that you leave behind when you're using a mobile device. But then organizations need to ask themselves, what do they do with all that data exhaust? How do you make use of it? Today, when we read about the big data scientists, when we read about all of those models that can be built about individual data, we really find that organizations have a very ad hoc approach to how they're recording and building those models. And what we're trying to do here at Trust Layers and what we've been validating with our customers to date is how can you do that at greater scale? How can you do that in a more systematic way and establish a set of proper policies and then be able to monitor that data use as it's being used? And so when you think about the collection capabilities, a lot of organizations do a fantastic job more and more of letting consumers know the data that's being gathered about them, letting individuals have the proper notice and choice about the data that's being gathered about them. And then organizations really go to great lengths to secure that data. And you want to make sure that the data isn't leaking out. You want to make sure that nobody is breaking in. And you can set up all the anomaly detection in the world. And ultimately, you want to make sure that data is secure. But what is the next step? Where do you go from there as an organization? Once it's collected, once you start to correlate all this data together, how do you then catalyze it responsibly? You need to make sure that you're not just understanding who is accessing the data in the organization, but you need to understand at a very granular level, how is that data being used? How is that data being shared? How is that data being moved around? And this is where we're taking my co-founder, Danny Weitzner, my co-founder's prescient research that was done at MIT and commercializing it for healthcare enterprises. We're commercializing it for the life sciences world, for financial services, and across the government sector. So all of you out there, when we're talking about big data today, I would encourage you to think not just about who's accessing all of that big data, but how is that data being used and monitored at scale? Thank you.
Thanks, Adam. My name is Andy Palmer. I'm an engineer, so hopefully a lot of you guys are engineers as well. And we just want to take a few minutes and describe my latest project, which is called Tamr. And we're really lucky to have a great group of people, about 30 people or so in Harvard Square, and we're having a ton of fun building really cool stuff and deploying our solution for companies like Thomson, which is a fantastic early adopter here in Boston. I mean, one of the best things about the ecosystem in Silicon Valley is this tight collaboration between people using software and people building software, big companies and small companies. And Thomson's been amazing at being an example of a big company in Boston that's doing incredibly innovative things by working with lots of innovative small companies. So, and credit to Mona for most of that. Tamr, I'll do like an Adam-like survey. So, how many of you have ever taken two spreadsheets and combined them together? All right, everybody. Imagine you were doing that times 15,000, and that's really what Tamr does automatically, is allow you to take lots of very disparate data sources and aggregate those sources together and understand the differences between all these sources, and then make it easy to do that over and over and over again over time. Ultimately, you have sort of really interesting sort of cross section here from the way to store data and operate on the data mathematically in Paradigm 4, a way to connect the data together using something like Tamr, and a way to control the use of the data and prevent misuse of data the way that Adam's solution does. And this is one of the best things about the community here in Boston is we've got the entire ecosystem of big data represented across a broad swath of both startup companies and very large companies. And so regardless of where you're looking to work and what you're looking to do, whether it's further down in the stack, things like database engines like Marilyn's working on, which are really cool and very interesting, all the way up to the stack to one of the other speakers that Mona's had, Ben Fry, who's one of the world-class leaders in data visualization. Ben is really exceptional. And so regardless of what you're interested in at what point in the stack, there's something for you in Boston. And I encourage you to, if you don't find something that fits your interest, to keep looking, because they're definitely out there and network. A little bit more about Tamr and what we do. One of our early adopter customers is a large biopharmaceutical company here in Cambridge called Novartis. And the folks at Novartis use our Tamr system to connect all the biological assay results data that's generated by 8,000 plus scientists every single day. And rather than trying to get all of those scientists to take their individual spreadsheets and use the same column names and to use all the same terminology and all the same stuff, instead they kind of say, well, we'd like it if you'd standardize, but we kind of know you're not going to do that. And so just put all this stuff through Tamr after you load it up. And what Tamr does is create all the connections between all these different spreadsheets and lets people view it in an integrated way, either to find experiments that are similar to the one that they're running or they're submitting, or to identify sort of patterns across all these different experiments. I want to see all the different experiments that were run around a certain biological pathway, around a certain biological target. And that becomes really easy if you can do this bottom-up or probabilistic data integration. And this is really what Tamr is all about. Doing data, it's an interesting time to be in data science, and I think we experience this at Tamr, and I know that my colleagues do as well, that this is not just about technology anymore. Actually, it's much less about technology now than it's ever been, and it really is much more about people. It's about people like yourselves that are interested in data science and data engineering and data technologies. That this is not the early 80s, like, Marilyn and I have this partner, Mike Stonebreaker, who invented, one of the earliest database systems. And really, like, these systems that we need to process data, and you say, like, there's one of almost everything you need out there in some way, shape, or form, right? One size does not fit all, but the question is, which size is right for any given workload? And I think this is a challenge that many of you have as kind of the up-and-coming data scientists in the area, that you're going to have an opportunity not only to sort of, embrace these cool new problems in data science, but to take many of these technologies that have already been developed, and many of which have been developed in and around Boston here, and actually apply them to do amazing new things. When you do correlation analytics in Paradigm 4, to people that have done this kind of work before, it's like magic, right? Something that took days to run now actually takes seconds. It's fantastic. And when you see this kind of, sort of these bells go off for people, you realize how transformative that can be. And we all take it for granted. At Tamr, it's things like, how many people, all right, I'm big into Adam's polls, right? So how many people have used Google Maps, right? How many people have used Apple Maps? Yeah, right, not really that good, is it? No, but in Google Maps, you say, well, how is it possible that they maintain all of this information across, such a broad, spectrum of different data sources? And how is it always accurate, right? You want to find the local coffee shop down the street, like it's all there. And the only way they do that is through this distributed curation activity, right? And it was amazing as we were starting Tamr. One of the things that again, Marilyn's my mutual partner, we did is go out to Google and describe what we're doing and this pattern for using probabilistic approaches to doing data integration, and then using humans to help augment the probabilistic models that we were generating. And the Google guys kind of looked at each other and they looked at us and they're like, hey, that's what we do for maps. It's the same thing. Right? We run these big machine learning algorithms to try and learn as much as we can about the data, and then we generate very, very specific questions that we send out to people. Sometimes those questions are to a small business owner themselves and say, hey, we're just trying to validate your address. Is this the right address for you? And you probably yes or no, and then that thing goes in, and this is the only way you can possibly curate that scale of a data source is by really, really aggressive use of machine learning, plus a lot of very directed human curation. And so these patterns, right, and how data systems are used and how they're applied are things that the more of that you pick up, right, the more patterns that you know and you see, the more powerful you're going to be over the course of your career, and the more value you're going to bring to whatever company that you join. Because again, these technologies exist out there, right? If you wanted to go out and say you wanted to go to work for some cool new e-commerce company in Boston, and they were trying to figure out how to do sort of this large-scale curation, you'd have the ability to go and pick out Tamr and apply that and see how it works, or use something like Paradigm 4. And so you don't have to actually understand everything, right? But being aware of everything that's available to you, all the tools that are available to you, is an incredibly powerful thing. And if you do that, one of the best parts about having this kind of event here at Thomson Reuters is this is what Thomson does incredibly well. They have so much data at Thomson about so much, many of the kinds of data that Adam was describing, right? You'd be shocked to know what they know about you. But what you really want to do is, like they do at Thomson, survey the landscape, see all the tools that are available to you, so that as you take your first or second or third job, that you can start to do this pattern matching and apply these state-of-the-art tools to match whatever workload you have, and hopefully for your employer, for whoever you're working for, you start to create some of that magic. Right? You want to create that moment where they believe that they can do things with their data that they thought was previously impossible. For those of us that were around before Google Maps, we know how incredible Google Maps is, right? But you can do the same thing in each one of your companies. You can create that magical moment for each one of your users. And again, I hope that if it comes to data curation, that you'll think of Tamr, but there are many, many more companies in the Boston ecosystem. So I'll wrap up with that and hand it back to Mona.
So I want to ask just a few questions and then open it up for you guys. So hopefully you have some great questions to ask. So I'll start with you, Marilyn. I'm assuming some of the people in the room are thinking about becoming entrepreneurs and thinking of their business. And Obviously, big data has been evolving alongside the open source movement. So I wanted you to talk a little bit about the open source version of SciDB in your business and some of the advice about how to be an open source company.
Yeah, great. So I am a huge believer in open source. One of the things that's about it is you have a lot of people trying your product and a lot of use cases that you wouldn't have gone after. So it's a great way of finding use cases, of finding out what your product needs to be more valuable to other people. And I want to tell you one great story, which was I was at a big data conference a couple of years ago, and a guy stood up, and he was from the NIH, from the 1000 Genomes Project that a bunch of you may have heard about, and he's frickin' giving a talk about building the 1000 genome browser on top of SciDB. We never knew. There was this guy whose name was like Slata D who was asking some questions on the forum. We didn't know what he's doing. That turned out to be really important for our business because one of the critical verticals, one of the verticals where we're working a lot in is in the bioinformatics and clinical informatics space. Having a community enriches your product and opens your mind. So that's the great part about it. It also makes for better products because you got all these people doing QA for you on your product. But how do you make a business out of it? The way that we're making a business out of it is we've got some extra functionality that isn't available in the open source version. So anybody can play with the open source version, and it's pretty powerful. It's at scidb.org/forum. But if you want to use it in a commercial setting, in a research science lab, you're going to need a lot of extra functionality for user access control, roles and responsibility, for redundancy and high failover. We also provide go faster buttons for some of the key math functions and some additional math functions that aren't available out there. So we create value for the enterprise edition over and above the open source.
That's great. So Adam, you were talking about data use, and so a lot of companies are building analytical model and predictive models, and so what are the ways they can get in trouble with their data use?
Well, I think what we see with a lot of our customers is they're really good at building those predictive models, but what happens is they get themselves out on a ledge in being able to really understand how the data is being used. How did I draw those correlations between all of these various data points and make a decision about an individual? You look at how people used to receive decisions about the credit scores. There were, a discrete set of, call it 20, 50 different inputs, but that doesn't work anymore. You've got thousands and thousands of data points that you draw correlations together, and you catalyze your data, and you build that predictive model. And being out on a ledge, you really need to have that confidence that the data is being used properly, and that's just sort of one of the ways we see folks really needing to be able to monitor how the data is being used, not just who's accessing it and the importance around the roles and privileges.
So you and I've always talked a bit about this. Are you seeing as more companies have big data strategy, are they getting a little bit more aware of how hard the data diversity problem is, and that not all the data is the same sort of structured, transactional, and that, because you're addressing that. Is this happening now, becoming more mainstream?
Yeah, and as Marilyn mentioned before, this data variety thing is a real problem, right? Like all we have to do is look at our own hard drives to kind of see the reality of that. So the diversity of data in an enterprise is driven not only by the fact you've got lots of different people creating data, but you also have different organizational structures, whether these are geographic or whether it's sort of this week you're going to organize a company one way and the next week you're going to organize it a different way. Though all those changes and all those organizational boundaries that people set up, whether real or artificial, create these artifacts of, we call them data silos, that exist all over the organization. And so if you come in and you're a new person coming into an organization, it should be as easy to find a data set that you need as it is to go on the web and search Google and find somebody's website. And we just think the same thing has to be true about data, that you're new, you come into an organization, you should have a catalog of all the data that exists and is available, and it should be pre-connected or pre-prepared for you.
Well, that would be pretty awesome.
Yeah.
So, on that happy note, I'd like to open it up to the floor. So please wait for a mic and let us know who you're asking the question to.
So my question is, nowadays we talk about big data and the importance of the vast amount of data, but I recently noticed that the Star supermarket, Shaw Market, actually they discarded their reward program. And I'm just wondering, probably to some extent, at a certain point, there will be a, we would like to have a stop in the amount of data we have so far. So I'm just wondering whether you guys would like to share a little bit about, your perspective about the amount of data that is sufficient for you to probe into a complicated situation. Thank you.
Who wants to take that?
Well, it's interesting that you mentioned loyalty cards. I'm not sure most people are aware at how much use of that loyalty card data has occurred historically. And a lot of people out there see the shopping experience in general, not of one as the last line in delivery of a good, but more about building a relationship with that consumer, that shopper, and then building a profile about a longitudinal profile about what they're shopping for and what their likes are, and really knowing about them and their behavior. And what I talked about before with being able to collect more and more data about us as individuals and being able to correlate it even more, you really don't have to just rely on the loyalty card data anymore. You can build all kinds of information. I mean, especially as we do more and more purchases with our phones, you can do correlations against the device identifier, correlations against whatever people are logging into with a particular app, and it's about a value exchange at that point. I think one of the challenges with loyalty cards was historically people didn't really understand that value exchange. You actually get a tremendous amount of value about relevant coupons, relevant content, relevant end cap displays that are more attuned to who you are as a shopper. And the future of that is really building those profiles. It's going to give you more relevant information, but you also, people need to understand about how their data is being used. And if you look at the interview that Tim Cook did with Charlie Rose last night, talking about how privacy is going to change how data is being used. And when an organization as large as Apple comes right out and says that, every organization needs to account for the proper use of their data.
My name is Thomson, and I'm a PhD student from MIT. Question, one for Adam and then one for the panel. Adam, your trust layer, you mentioned, seems to be something that you guys are developing for companies to help them build coalitions about their customers or the consumers. And I was wondering, is there something, any thoughts about whether you would ever build something for the consumer side in order for them to understand what types of information have been compiled compiled about them, so that they may maybe get a better understanding of how these certain decisions that seem to be just independent, they may be being used to learn about their behaviors. And then for the entire panel, we've heard about 3 great companies and products here, and I was wondering, when you hire, or one, if you're hiring, and 2, if you are, what types of skills and experience do you look for in potential new employees?
So I'll answer that quickly and then hand over. I think consumers want to know that. They really want to understand, how is my data being used, and to what degree can I control that? When you're talking about especially talking about that conversation between an individual and a private company, you need that value exchange. You need the consumer, the individual, the patient, to really understand how valuable is that and what am I willing to trade off for it in terms of privacy.
There's a
value.
model with credit, right? It's kind of what happens with credit reporting right now, right? So I think that a key thing for trust layers is that everything should be like credit reporting, right? Like if somebody's accessing your Google profile to find out some information that they're going to use to make a decision about healthcare insurance or something, like you should have knowledge of that. Whereas right now, it's kind of, who knows what Axiom's doing with your stuff, right?
Mm-hmm. And who knows what needles are being pulled out of the haystack relative to you and why. And those needles were pulled out and it's all okay because, right? Organizations don't have a mechanism for that.
One of my favorite trust layers stories, sorry to talk about trust layers, but one of my favorite trust layers stories is they talk about not Big Brother, but Little Brother. And so there's all these license plate readers now that have been deployed very broadly in law enforcement. They're everywhere. And the biggest concern around privacy is not like, some, NSA agent watching you and tracking you, but rather it's the ex-husband of someone that's going in and following and stalking that person. It happens all the time. It's terrifying. And like the only way you figure out if Little Brother is doing the wrong thing is if you do this mashup of sort of log files and policy data like you get at trust layers. It's like this whole 1984 thing is really not about the institution. It's about all of us behaving badly potentially. Yeah.
Oh, and we are hiring, yes. We're looking for people who really are passionate about the accountable use of that data, accountable use of personal data in a big data world. I mean, that's really the big, bold vision we've got.
So we're hiring in the data lab. A lot of big companies are setting up data lab. I feel like it's us and everybody else in the world. We have diverse data sets and fundamentally really exciting different sources of data, all the way from the news to the scientific data. So we're really looking for people that have a strong natural language processing, comfort with text, very curious, willing to do rapid iteration. I think one thing that's common probably to all of your companies and ours is this idea of working like a lean startup and being agile and doing rapid iteration and rapid experimentations, and really looking for a combination of strong understanding of the text format and some experience in the standard sort of computer science with machine learning and things like that.
Yeah, we're hiring really aggressively at Tamr, and we like to think of these skill sets in three buckets. The first is data engineering, which is more like the best skills there are like data systems people, right? People that are hardcore systems engineering. The next level up for us is data science. So these are probably people that are really skilled in statistics and math and like writing algorithms and like applying algorithms to lots of data. The skills there, Python, R, I hate to say SAS, although, like I freaking hate that system, but and then at the next level up, for people that are more sort of business oriented and kind of maybe a little bit less technical, decision science, the process of identifying what decisions are being made and doing the analytics and engaging with the people making those decisions to make sure they translate that into something that can be supported by data science. So I think of things in those kind of three buckets, and we hire people at data engineering and sort of the data science layer. Yeah.
We're looking for people that have this sort of startup mojo mentality. And it's a different world when you're in a startup. It's no way is it a 9-to-5 job. You just get consumed and you're part of a team that's consumed about trying to get something done today, and it matters that you get it done today versus, oh, I'll come in and do it in the morning. And it's people that like to engage sort of at all levels, because you can't be siloed in a startup company. You can't say, oh, I'm the query optimizer guy. The point is, you really have to understand what the customers are doing with the product, because in a lean environment, you don't have time to just build textbook perfect products. You got to have a really good understanding of what's good enough. And the only way you're going to know what's good enough is to understand what people are trying to do with your product and how they use it.
Yeah, I think that's a really good point. Really listening to your customers is important, and perfection is definitely your enemy in a startup. We really focus on solving those problems and not working the long hours, but just really work the job, not the hours.
One other thought too, in this world, I think that bigger companies have a huge advantage in that they have the data. And this is one of the things that's plaguing the database research community, is that there are a lot of computer scientists out there doing research without any data, right? So they're doing data, like, it seems crazy, but it's kind of true. And so I think that a huge advantage of being at a place like Thomson Reuters or Google is that you just have all this data and you can actually do real work. I had never worked at a big company until I spent 4 years over at Novartis, and like the cool thing about it was we just had data to work on. And if you're in a startup or like a third-party software vendor, like, you don't really have that advantage. And so I encourage you, if you're going to do this, like, go someplace where you've got data to work on, right? And you're not necessarily just sort of living in a bubble. Yeah.
So I've been told it's time to go to the networking reception. So thank you so much for your questions. Thank you so much for being here, and see you at the next event. Thanks to the panel.